go over the solution to question 1 of even more circuit exercises. We have a circuit with 3 light bulbs and there's a switch. When the switch is open, bulbs A and B are in series. When the switch is closed, bulb C is added in parallel with bulb B. What will happen to the brightness of the bulbs? I have a simulation of this circuit constructed in this PhET lab here. And you can see here are 2 light bulbs. The switch is open. So these 2 bulbs, right now they're equal brightness. What happens when I close the switch? Observe what happens to bulb A and B. When I close the switch, did you see A got brighter and B got dimmer? Open, closed. Let's explain why bulb A gets brighter and bulb B gets dimmer. Okay, we're going to do it like this. First, we're going to color code the pressure in the wires. Just coded the first circuit here. The voltage drops twice. And if these balls are identical, then the voltage drop over each bulb will be the same. Red to yellow is half the voltage of the battery, and then yellow to blue is the other half. The next thing we're going to do is think about how the total resistance of the circuit will change when bulb C is added. Here bulb C has been added in parallel with bulb B. When bulb C is added in parallel with bulb B, the resistance will decrease. Recall from class, when we studied resistors in parallel, that the resistance of 2 resistors in parallel is less than a single resistor. There are now 2 pathways for the current to flow through this circuit. Since there's 2 pathways, it's easier for current to flow. So the resistance is less if you add a bulb in parallel. How will the current passing through bulb A change to bulb C being added? How will this current change? Well, the total resistance of this whole circuit is now less, so the current increases. Less total resistance means the current through bulb A increases, and the current through the battery does as well. Let's see that in the simulation. Here I've added a current meter so we can see the current at that point in the circuit. When the switch is open and there are just 2 bulbs in series, the current is 0.6 amps. When I close the switch, you can see the current increases. Right now charge can flow through both these bulbs in parallel. Next, let's think about how will the voltage drop across bulb A change due to bulb C being added when we close the switch. Let's think about this voltage here. Or this voltage. Okay. When the switch is closed and bulb C is added, there's more current flowing through bulb A. And recall that voltage equals current times resistance. The resistance of the bulb hasn't changed, but the current has changed. So the voltage drop will change. The voltage drop will increase. Let's see that in the simulation. The voltage drop across bulb A is 6 volts. When I close the switch, the voltage drop is 8 volts. Right? Current increased when I closed the switch, and so did the voltage drop across bulb A. More current through bulb A results in a bigger voltage drop. The last thing to think about is how will the voltage drop across B change? How will this voltage drop change? Okay, we're going to apply Kirchhoff's voltage law to this part of the circuit here. got a battery with fixed voltage. Some voltage drops across bulb A, the rest drops across bulb B. Since there's a greater drop across bulb A, the voltage drop across B must be smaller because these two voltage drops add up to the voltage gain across the battery. This voltmeter is measuring the voltage drop across bulb B. You could see when the switch is open and it's just the two bulbs in series that both voltage drops are equal, and they add up to the voltage drop of the battery, which is 12 volts. When I close the switch, because there's more current through this bulb, the voltage drop across this bulb is bigger, up across the second bulb. See, just 4 volts. By Kirchhoff's voltage law, the voltage drops across the two light bulbs add up to the total voltage of the battery, which is 12 volts in this case. That's why bulb B gets dimmer and bulb A gets brighter when the switch is closed. Kirchhoff's voltage law, if the voltage drop across A, VA, increases, VB must decrease. Okay, I'm going to color code this second circuit so that we can see the pressure in the wires. You could see that when the switch is closed, because there's a bigger voltage drop across A, we go from red to green instead of red to yellow. And then there's a smaller drop across B, green to blue. Bulb A gets brighter and bulb B gets dimmer when the switch is closed.